Hi, this is Nirmala Rednam. In this video, we are going to continue the paper that we started. That is a 10th board exam paper that was conducted on 17th February to 2026. And we already finished section A, B, C, and D in the previous 3 videos. Today, we are going to complete the last section, section E. And with this, we will be finishing this particular set of basic paper, which is the second set, right? So let's look at section E. The first question here in section E is, in a circular museum hall of radius 14 meters, this is the hall in the picture, some statues are displayed. Statues are kept inside the inner concentric circle of radius 7 meters. One such statue lying on sector OAB. Now this is the top view of that particular museum that they have shown here, right? So let's focus on the top view that they have given. So one such statue lying in sector OAB is fenced along line segments OA, AP, PB and BO, where P is a point on the outer circle. Based on the above information, answer the following questions. First, we have to find angle AOP. Let's draw the figure quickly. So I have two concentric circles. This is section E, which has case studies. 36th question. Let us draw the figure. I have two concentric circles, right? And the center is O. We are looking at a point on the outer circle P, right? And you can see in the figure here that OA, these 2 points A and B are such that PA and PB are tangents to the inner circle. Now here, of course, if you read the question carefully, it is not mentioned anywhere that PA is tangent to the inner circle. However, when you look at the figure and if you were to even measure the angle OAP using a protractor, you would see that it is 90 degrees, and so PA is indeed a tangent. And that is the only way to justify the assumption that PA is tangent, because it is not explicitly given in the question that PA touches the inner circle, because that would imply that PA is tangent. And just going by the figure, and even if you were to extend PA further using a scale, you would see that it is not intersecting the inner circle at a second point. That means it's touching only at a single point, right? So that is the only way to conclude that PA is the tangent. And we are going to proceed with that assumption. The reason being, if it were not tangent, then it would be very difficult and probably impossible to determine the angle AOP, because then the given information would not be sufficient. Okay, so we are going to carefully assume. However, this is not an ideal situation, given the fact that if you remember in the previous section, there was a figure given where the figure was very misleading. So there we were not relying on the figure, right? But when it comes to this question, we have to take that piece of information as given from the figure. Although it is not mentioned, they did not mention 90-degree symbol at the angle OAP in the figure. But however, if you actually measure it using a protractor, or even intuitively, you can see that it's touching. And if you were to produce PA further, it is not going to, you will see that it is not intersecting the inner circle at any other point. That is the only way to justify our assumption that PA is the tangent. So here I have PA and PB as tangents, right? So let us say this is the tangent, this is the other tangent, right? That means this is 90 degrees and this angle is 90 degrees, right? Now in the first question, they are asking us to find the measure of angle AOP. So this is the angle that we are interested in, right? And we know that this is 7 meters, the inner circle radius, right? And the outer circle radius is 14 meters. So OP is 14 and OA is 7, because that's the radius given to us. OP is 14, right? So if I take cos theta, because then I'll be looking at adjacent, which is OA. OA by hypotenuse is OP. This is equal to 7 by 14, which is half. Because cos theta is half, I can say that theta is 60 degrees, which is nothing but measure of angle AOP. This is how we'll find the angle AOP. Now in the second question, they're asking us to prove that OAP is congruent to OBP. Okay, so we have these two triangles OAP and OBP. We're supposed to prove that they are congruent. So let us start with OP, which is the common side, right? And OA is equal to OB because that's the radius of the inner circle. And PA is equal to PB because you know that when you draw two tangents are possible from an exterior point onto a circle, and the length of the tangent is the same, right? So we know that PA is equal to PB. That means by SSS congruency, we can say that triangle OAP is congruent to triangle OBP. This is your second question. Next, moving on to the third question. They're asking us to find the length of the fencing required to protect the statue. Now, the fencing, if you look at the figure, is OA plus AP plus PB plus OB, right? So, fencing length is equal to OA plus AP plus PB plus BO. Now OA and BO are nothing but 7 meters, and now I have to find the length of PA and PB, right? So let us do that. PA is equal to OP sine theta, right? Which is nothing but OP is 14 times sine 60. Sine theta is sine 60, which is root 3 by 2. This is equal to 7 root 3 meters, correct? So now the length is equal to 7 plus 7 is 14 plus again 2 times of this is 14 root 3 meters. That is equal to, if I take 14 common, I get root 3 plus 1, 14 into root 3 plus 1 meters. So this is the fencing length. In the question, they have asked us to take root 3 as 1.73. So 1.73 plus 1 will be 2.73. So 273 into 14, right? So when we do this, we get 28, 29, 10, 273. So I have 2 decimals, 38.22 meters. So this is the length of the fencing, right? So there's an internal choice here, and they're asking us to find the area of the quadrilateral OAPB. So let's look at the figure. Now this is four-sided quadrilateral OAPB, right? Now we know that these two triangles are similar. So if I find area of this, then twice of that is going to be the required answer. And when I want to find area of a right angle triangle, we simply take base into the other two sides other than the hypotenuse. So this is 7, and AP we have already calculated as 7 root 3 over here. So AP is 7 root 3. So I will have half times 7 into 7 root 3. So let's write it down. Area of OAPB is equal to twice of area of triangle OAP, right? Which is twice of triangle area is half into base. I'm taking the base as this is the triangle OAP and this is the right angle. So I'm taking the base as OA, right? And the height is going to be AP. And I know both of these measures. I can cancel this. And OA is 7 and AP is 7 root 3 square meters, right? So this is 49 into 1.73. They've given us the value as 1.73. Otherwise, we would have left it at root 3. Once they have given the value of root 3, we have to use it and find the final answer. So now here 173 into 49 is 7, 65, 15, 12, and 29, 6, right? So 7, 7, 4, 8, 2 decimal places. It is 84.77 meter square. So this is your area of the quadrilateral. Now let's look at the next question. 37th question. Seema daily goes to a park to exercise on machines available there. When Seema spent 15 minutes on exercise bicycle and 30 minutes on double cross walker, she received a message of burning 435 calories on a fitness watch. When she spent 30 minutes on exercise bicycle and 40 minutes on double cross walker, she received a message of burning 690 calories. To find the number of calories burned per minute on each machine, answer the following questions. Okay, so this is the next question. So the figure there is the park where Seema goes and does the exercise on bicycle and a double cross walk, right? So now the first step is to represent the given situation in terms of a pair of linear equations, right? So let us do that. In order to represent it in terms of an equation, we need to assume the variables. That's the first step, right? So first we are going to say that we are talking about calories burnt per minute. So I'm going to assume X as the number of calories burned per minute on the bicycle, right? On the exercise bicycle. And Y is the calories burned per minute on the double cross walker, right? So first step in linear equations or any algebra, first you need to define your variables clearly. Now let us write the given information in terms of equations. Now they're saying that 15 minutes spent on exercise bicycle, what will be the calories burned? 15x, right? And 30 minutes spent on double crosswalk, so 31, right? This is equal to, this should give us the total calories burned and it is given as 435, correct? So I'm going to simplify this in the 15 table. This will give you x plus 2y is equal to 29. This is my first equation. Next piece of information given is 30 minutes on exercise bicycle. That means 30x is the calories burnt on exercise bicycle. And you have 40 minutes on the double cross walker. So 40y is the calories burnt. Total calories burnt is given as 690. Again, I'm going to simplify this by using the 10 table. 3x plus 4y is equal to 69. So now these two equations is the representation of the situation in terms of a pair of linear equations in two variables, right? So that is the first question that they have asked. Let us look at the second question. Show that the equations have a unique solution. when do we say that a pair of linear equations has a unique solution? When the ratio a1 by a2, that is coefficients of x, is not equal to b1 by b2. In this case, it has a unique solution, because if this ratio is equal, then these are parallel lines, and that means that they do not intersect at a point, and which means that there is no unique solution. So if I can prove that a1 by a2, which in this case is 1 by 3, and b1 by b2 is 2 by 4. 2 by 4 is equal to 1 by 2. Are these equal? No, they're not equal. Therefore, hence it has a unique solution, right? Next question. They're asking us to solve the two equations using elimination method. So here, when we are talking about elimination method, these are the two equations. What we are going to do is try to eliminate one of the variables by making the coefficient of that particular variable same. So here you can clearly see that if I multiply this by 2, then I can eliminate variable y. If I multiply this by 3, I can eliminate the variable x. So let me multiply this by 3. Okay, then what we get is 3x plus 6y is equal to 29 into 3, which is 87. The second equation as it is, 3x plus 4y is equal to 69. Now when I subtract these two equations, x gets cancelled and I have 2y is equal to 18, implies y is equal to 9. Now if y is equal to 9, I can substitute in one of the equations and find x. Okay, so if y is equal to 9, this is nothing but 54. 87 minus 54 is going to give me 33. So 33 by 3, 3x is 33, so x is equal to 11. Now this is your a bit. Or the internal choice is you have to find the values of x and y using substitution method. So what are we going to do in substitution method? You take one of the equations in order to write x in terms of y or y in terms of x. Here you can see that x is already having coefficient 1. So I'm going to write x as 29 minus 2y, right? So let me write x is equal to 29 minus 2y. And now I'll substitute this in the second equation, which says 3x plus 4y is equal to 69, right? So here 29 into 3 is 87. Okay, so I'm going to write 87 minus 6y plus 4y equal to 69. So I'll take y on one side and the constants on the other side. I'll get 2y is equal to 87 minus 69 is 18. Okay, implies y is equal to 9. Okay, so we've got the same answer. So that means our method is, there's no mistake anywhere. And x is equal to 29 minus 18, which is nothing but 11. Right? So now what are x and y? X is the calories per minute burnt on exercise bicycle, and y is the calories, number of calories per minute burnt on double cross walk. So this is your 37th question. Now let's look at the 38th question, which is the last question. So they have given figure of a mushroom. Let's read the question. There are many varieties of mushrooms available in the world. One such mushroom, Amanita muscaria, has an upper part which is like red cap, hemispherical, and lower part is like a cylindrical white stem. The hemispherical cap's radius is given as 3 centimeters. The cylindrical stem is 2 centimeters high with diameter 1.4 centimeters. Considering mushroom a solid object, answer the following questions. What is the total height of a mushroom? Find the volume of the stem, determine volume of 7 such mushrooms, and total surface area of 7 such mushrooms. So these are the 4 questions we need to answer. First, let us draw the figure. Right? So here I have a mushroom which has 2 parts, cylindrical and hemispherical, right? So this is the last question. And let us draw the figure. I am going to draw the cylindrical part first. So here this is the stem part of the mushroom, and then I have the hemispherical part on top of it. Okay, this is the hemispherical part, and although not given, we are going to assume that the center of this hemispherical part is going to coincide with the base, center of the base of the cylinder, because nature has symmetry. And again, like in the previous case study question, you won't be able to solve it if you don't assume that. Okay, so now in the figure they have given some information. Let's quickly write down that information here. I'm going to name the center as O, okay, and let this be A, and if I draw the central vertical line, I'll call this B and C. BC is the radius here, and I'm going to extend this to touch the hemispherical part and call it D, right? So now, according to the given information, the radius of hemispherical part is 3 centimeters, and the height of the cylindrical part is 2 centimeters, and the radius of the cylindrical part is half of 1.4, which is 0.7 centimeters. They're given the diameter as 1.4, so radius is going to be 0.7 centimeters. First question that they're asking us is, what is the total height of the mushroom? That would be, in this given figure, we have labeled it as BD. This is the total height, right? BD. Now in that BD, we have 2 parts, BO and OD. Now BO is given as height of the stem as 2 centimeters, and OD is nothing but radius of the hemisphere, which is 3 centimeters. So the total height is going to be 5 centimeters, right? So this is the height. That is the first question that they have asked. Let's look at the next question. Find the volume of the stem. Now stem is the cylindrical part, right? And you know that the volume is given by pi r square h, right? Now I'm going to write this as 22 by 7. Now for the stem, r is 0.7. Let me write it as 7 by 10. R square h. Now height of this cylinder is 2, right? So this is height of the cylinder, OB is 2, right? And the units is centimeter cube. Now if I cancel 1 here, I have 44 into 7, right? Which will give me 308, and I have 2 decimals. So this is 3.08 centimeter cube. This is the volume of the cylinder, right? Next question, they're asking us to determine the volume of 7 such mushrooms. Okay, so in order to find the volume of the mushrooms, 7 such mushrooms, so 7 into, I have 2 parts here, the cylindrical part and the hemispherical part, right? So the cylindrical part is going to be, the volume is 2 pi r h, sorry, pi r square h, right? The volume that we've already seen, the cylindrical part is going to be pi r square h, and I can directly write 3.08 because we have already calculated it. This is the cylindrical part. Now what about the hemispherical part? It is 2 by 3 pi r cube, capital R, let us assume, and we know that R is 3. So if I simplify this, I get 2 by 3 into 22 by 7 into r cube is 3 into 3 into 3. Now 1 3 will get cancelled here. Okay, so I'm going to write this as 44 into 9. Let's calculate. 44 into 9, 9 4 is 36, 396 by 7. I'm not simplifying it further because when I calculate for 7 mushrooms, this is going to get cancelled. Centimeter cube. Okay. Now I have 7 into this is 56, 21.56 plus, now like I said, this will get cancelled and I have 396 centimeter cube. Correct? So when I add these two, I'm going to get 417.56 centimeter cube. So this is the volume of 7 such mushrooms. Okay. Or the internal choice question is total surface area of 7 such mushrooms. Now here they're asking the total surface area of 7 such mushrooms. Now here I need you to look at the figure very carefully. What constitutes the total surface area? Now clearly the curved surface part is one of the parts that we are going to consider, which is 2 pi r square, correct? And one is the lateral surface area of the cylinder, which is 2 pi r h, right? So 2 pi r h is clear and 2 pi r square is clear to us. Now coming to the base, I have pi small r square. This is part of the total surface area, and you also have under the mushroom, under the curved part of the mushroom, there is an annular region here which you need to consider, right? Because it is fixed to the stem only at this part, correct? So this part also belongs to the surface area. When you're finding the total surface area, you have to consider that as well, because this is not the lateral surface, it's a total. So base definitely comes, and this is part of the base of the hemispherical part. So if you look at that, then 2 pi r square is very clear. There is no dispute there. And 2 pi RH is clear. This is the lateral surface area of the cylinder. I have the base of the cylinder pi r square, and the annular region is nothing but pi r square minus r square. Correct? Now what is going to happen is this is going to get cancelled with this, which you can see in the figure itself that you are subtracting this part and you're adding this part. So if you combine this, it's simply pi r square. That's what we're doing here. Okay, so I have 3 pi r square and 2 pi RH. Now we need to carefully simplify this. Okay, now I have I need to consider 7 such. So let us say 7 times of this, 7 such mushrooms, right? So 7 times of this. I want the 7 to be included right in the beginning so that 22 by 7, the denominator gets cancelled. And so I have here, I'm going to take 7 pi outside. Okay, 3 r square. Capital R is 3, so 3 into 3 into 3 is 27. And 2 RH, right? 2 into small r, which is 7 by 10.7 into h, which is 2, right? So this is 28 by 10, which is 2.8. Okay, so now I have 7 and 7, like I said, will get cancelled. 22 will be remaining and 29.8, and this is square centimeters, right? So I have 298 into 22. Okay, this will give me 596, and when I add this, I get 6556 with 1 decimal. So 655.6 centimeter square. So that is the total surface area of 7 such mushrooms. So this calculation needs to be done very carefully. So with this, we complete this paper, that is the basic paper, set 2. And in this paper, in this particular paper, we have seen a couple of inconsistencies. One is in the diagram where we were given a triangle. That was quite misleading. And in the case study, we were compelled to make a very important piece of information had to be assumed from the figure that they have given to us, that PA is tangent to the inner circle. So these are a couple of things where, in the exam, in the environment where you're already under stress, this could have created a little bit of nervousness and tension among students. So these couple of points could have been taken care of. Now in the coming videos, I will be solving the other sets, the other 2 sets of basic and the 3 sets of standard as well. So stay tuned.